Today, we're jumping into one of the most famous and, let's be honest, one of the absolute weirdest ideas in all of science. It's a story about a cat, a box, and, well, the very nature of reality itself.
Seriously, just take a second and think about that. It sounds completely impossible, doesn't it? It's a total contradiction. I mean, in our world, things are one way or the other. A light switch is on or it's off. A cat is alive or it's not. But here's the thing. The world of tiny, tiny particles, the quantum world, it just doesn't play by our rules. Down at that scale, things can actually be in multiple states all at once. And that one bizarre fact is what leads us to a cat that is somehow, impossibly, both. So how in the world you get an alive and dead cat? It all starts with this incredible thought experiment, one that was specifically designed to show just how bonkers the quantum world really is. You know, Erwin Schrödinger wasn't actually trying to prove that a cat could be some kind of zombie. Not at all. He was actually pointing out a huge problem. He was basically saying, look, if my quantum equations are right, then the world has to be as weird as this cat in a box. And he really wanted his fellow physicists to wrestle with that absurdity. Okay, so let's break down the setup. Imagine everything is linked together in a kind of grim chain reaction. The cat's fate is completely tied to a single tiny atom. This is a concept called entanglement. If that atom decays, which is a totally random quantum event, a vial of poison gets smashed and the cat dies. If it doesn't decay, the cat's perfectly fine. And the key part is, we have no way of knowing which one happened until we actually open the box. And this is where your brain starts to melt a little. The central idea here is something called superposition. In the quantum world, until you actually go and measure it, that atom isn't decayed or not decayed. It exists in this fuzzy probabilistic cloud of being both decayed and not decayed at the exact same time. So here's the big leap. Because the cat's life is entangled with that atom, all that quantum weirdness gets scaled up to our world. The math is relentless. It insists that the cat itself must also be in a superposition. This isn't just about us not knowing if the cat is alive or dead. The theory says the cat is, in a very real sense, both alive and dead right up until the moment we look. This right here is the heart of the paradox Schrödinger wanted to put on display. It forces us to ask this incredibly deep question. How does the fuzzy, anything is possible quantum world somehow turn into the solid, definite reality that we all experience? This really lays out the conflict perfectly. You've got the quantum view, which describes the system as this wave of possibilities. The cat is alive plus dead. But then there's our regular classical experience that just screams that's nonsense. In our world, the cat has a definite outcome. It's either alive or dead. We just don't happen to know which one yet. And this fundamental clash has a name. It's called the measurement problem. And it is, without a doubt, one of the deepest, most nagging mysteries in all of physics. What is it about the act of measuring, of observing, that forces the universe to just pick one reality and stick with it? Let me put it another way. The math of quantum mechanics is amazing at predicting probabilities. It's fantastic at that. But what it doesn't tell us is how you get from probably this or maybe that to definitely this. Why does just opening the box suddenly change everything? As you can probably guess, a problem this big has attracted some of the most brilliant and creative minds in physics. And they've come up with some truly mind-blowing potential answers. For almost 100 years, this wasn't really a physics problem you could solve in a lab. It was a philosophical one. There was just no experiment you could run to prove one idea was right and the others were wrong. It was basically a battle of interpretations. Okay, so here are the main contenders. First up, you have the classic Copenhagen interpretation. It basically says that the act of looking forces reality to collapse into just one state. Then you've got the sci-fi sounding many worlds idea. It says there's no collapse at all. Instead, the whole universe splits, creating one reality where the cat's alive and another where it's dead. And finally, there's decoherence, which suggests that the superposition is just super fragile, and tiny interactions with the outside world make the quantumness leak away almost instantly. So we were stuck. A collapse, splitting worlds, or a leaky environment. They were all fascinating ideas, but with no real way to test them, it was just a deadlock. That is, until maybe now. All right, this is where we get to the really cutting-edge stuff. A new theoretical proposal suggests that maybe, just maybe, we don't have to be stuck in this philosophical argument forever. There might actually be a way to test it.
This is the million-dollar question. See, opening the box is a big, clumsy, destructive measurement. It forces an outcome. But what if there's a gentler way? What if we could get information about what's inside without completely shattering the superposition?
The idea is to use a single quantum particle, let's say a neutron, as a kind of spy. You could fire it at the box in a way that it can sort of feel what's inside without totally disturbing it, almost like a ghost passing through a wall. And then we measured that spy particle after it comes out the other side.
So here's how it would work. If our neutron spy interacts with a living cat, it gets a tiny, tiny nudge. If it interacts with a dead cat, it gets a slightly different nudge. But, and this is the key, if the cat is in a superposition of both states at once, the neutron interacts with both possibilities. Think of it like a single ocean wave hitting two different rocks at the same time. It creates a very unique ripple, a special kind of interference pattern. And finding that specific mathematical ripple, that would be the smoking. And that would be the breakthrough. If we could actually run this experiment and find that exact interference pattern, it would be the first direct empirical evidence that a large, everyday object can exist in a quantum superposition. It would prove the cat was, for a fleeting moment, truly both alive and dead. So what does all this mean? Well, as a source material puts it so perfectly, this new idea completely reframes Schrödinger's cat. It's not just a philosophical puzzle for us to argue about anymore. It's a new frontier for experiments. It's a real challenge, pushing us to find out if the absolute strangest parts of quantum theory aren't just equations on a blackboard, but are in fact the fundamental way our reality works.